So as I've been updating my schematic, I thought it might be interesting to take a look at an updated PCB. Maybe a couple of real quick changes I've made to my schematic. I do now have an Arduino debugger added, and you can see how I'm connecting it up, but basically connecting in all my bus data lines and address lines, along with the clock, some of these bus cycle signals, different output enable signals for all of these different net labels that you see, and then whether the processor is reading or writing. So I've added that. I still do have some of these status LEDs that still will be helpful if I'm just single stepping through things and not necessarily using the Arduino debugger. I have updated my ROM to use actually a slightly different chip. It's the the 20 chip, which is half the size of the previous ones. So a pair of these will give me my half megabyte. The only real benefit there, it's not saving me any physical space, but it doesn't use this one extra pin, which would be that final highest address line, address 19. So I'm using 1 through 18. But when it comes to actually writing these flash chips, though, it should write twice as fast, since there's half as much for me to write out when I go to program them. Other things in here, I do have an ISA bus that is not planning to use any of the DMA type of support or the higher IRQs. I'm kind of just going to start simpler on that. And it's tying into all of these signals on the bus and other indicators. And then any of the ones that were unused, I just put into a pin header. So later, if I want to run some soldered wires to different things and tie in some of that, I could attempt to do that. I'm guessing at that point, though, I would have to add some logic ICs, and maybe that's something I could do to this circuit, is just give it a couple placeholders for some logic ICs. I don't know enough yet what that DMA stuff looks like yet, though, so I'm not going to bother with that for now, other than the pin headers. And then on my different I/O chips here, my PPI chips, I did have some unused ports on those, so I also put those out to pin headers, so that if I want to connect something to those ports later, bar graph or sensor or whatever it might be, I can easily do that. Or maybe SPI, maybe I'll use one of these. Maybe PPI2, I'll use these two ports to start doing some SPI type of communication, to be able to hook up any SPI type of device. So what I'm going to do here is I'm going to just quick save this, and I'm going to have it update my PCB, which I don't think there's any changes. And okay, no changes. But as I look at this, I can see some of those new things I did just add. Some of these headers, you can see the rat lines just showing they haven't been routed. So I'm going to go ahead and get these routed, and I'm going to actually use an auto router, but I'm not going to use the built-in router. There is this auto route in EasyEDA, and it's fine for simple things, but it does not work well for a board like this, especially if I'm doing only a 2-layer, which that right now, if I look at this is just a 2-layer board. So I have a 2-layer board, pretty simple. Maybe one thing I could do is update my design rule and increase the size of all of my power and grounds on here. So let me do that. I'll just call this power, and maybe I'll double those for now. Just messing around with this. This isn't super critical at this point. But then if I go down to my ground, let's see here, ground, I can set that to use this rule for power, and then I'll do the same thing for VCC. Okay, so now VCC and ground should have double the track width, so I'll save that. And then I want to actually do the routing in an external tool, so I'm going to come up here to route, and I'm going to export this routing information. And it looks like I've already got a file there. I'll just replace that. And then I'm going to flip over to this other tool called Free Router. And I'm going to open up And here I have this file I just saved. And I can see there is what I've got so far. And I'm going to basically go ahead and have it take a pass through routing this. So I'm going to hit auto router. And now down to the bottom, I can see that it's on pass 1 and how many it has to route and how many are failing. So we'll see if this can make it through and successfully route this or not. It'll take multiple passes and try to update and get these extra pin headers connected in. And so I'll let it run and see if it can come up with a successful solution. I can see it's failing quite a few lines. And it might be that I need to move things around a bit, which is definitely very possible. And I think where it's failing right now, this would be my ISA slot. And this new pin header I added, it's not real happy with that. So it could be that I move this pin header over to the left side of that ISA slot, or I spread it out and break it up into smaller pieces so that I don't have all of these consecutive pieces in a pin header that have to stay together, and that might leave some more room for things to be routed. But I'm going to go ahead and let this route just for a little bit here, and we'll see what kind of conclusion it gets to. If it does make it through this routing, it'll then get into like an optimization, a batch optimization phase, and that will run and run and run until I pretty much stop it, I think. But let's see what it comes up with. And then when that's done, I can import it back into Easy EDA and take a look at it there, and maybe take a look at what it's going to cost to produce a PCB that looks like this. Previous PCB that I had was a 4-layer, smaller, simpler PCB2. This one I'm cutting down to a 2-layer. The price difference is very significant when it comes to printing PCBs, whether it's a 4-layer or 2-layer. And it's not necessarily just the PCB cost. There's some upfront engineering work that you get charged for from JLC PCB when I do a 4-layer that I don't see those same charges on a 2-layer. So at this point, you can see that the auto router is flying through the passes, and I'm playing this back at 30 times playback speed, but it's flying through the passes and it's not making any progress. So I'm going to go ahead and stop it here and go back and make some changes. I'm going to go back to Easy EDA, and I think the changes that I'm going to make is to maybe separate this a little bit. And let me go ahead and just try pulling this out. So moving those out, spreading that out doesn't seem to be making a huge difference here. So what I'm going to actually do is go back to Easy EDA and delete all of the tracks, and that way there is nothing existing for my auto router to have to work around. And so you can see I've deleted all that. You can see the rat's nest here, basically all of these rat lines. And I'm going to go through the process of exporting, importing, and starting this over again in the auto router. And now it's moved past the actual routing and it's into the batch optimizer. And so I'm going to let this continue and at least get through one pass. And this pass will actually take a while, but I'll let it run and play this back at a fast speed. Okay, so that is finished routing. I'm going to go ahead and import this back into Easy EDA. And here you can see the updated traces. Now I'm going to refresh and check for any DRC errors. And that all looks good. So maybe I can save this and then go ahead and open up the 2D model of it and just take a look at that. And so this is what that looks like at this point. A lot of traces on a 2-layer board. And if I want to take a look at the 3D version of that, and this is starting to look like a PCB that actually could be workable. So I've left room on the far right for an Arduino. I've got my pin headers on the unused ISA slot connections. The ROM would actually go in ZIF sockets, so I've left plenty of room for those ZIF sockets. And there's some wasted space on the board, and that's all stuff I can try to compact this and bring it closer together. But at least I can kind of see what this board's starting to look like. And if I go in to see what the cost would actually be for this board, let me do that. So I'm going to go up here to my fabrication and pick PCB fabrication. And I'll double check the DRC. That should all be fine though. And then I can get a price, and it looks like 5 of these boards would cost about $40 US. So I might be able to trim down the size of this board a bit. There's a lot of traces, and you can see there's a lot of vias as you look through this board. But so basically $8 a board if I wanted to make a run of these, and I'm still not close enough to actually doing something like that. But this is getting closer, so maybe by the time I get said and done with this, I'm probably going to be at about maybe $10 a board. But hopefully in that board I would have things like, I've got the LCD here. Let me go back to the 2D view for a second. Got the LCD here. I've got 2 of these PPIs. I've got a spot to mount my PSOC. I may swap that PSOC out with actual independent 7400 series chips. We'll see where it ends up. But I've got the math coprocessor, I've got my clock generator, the bus controller, the PIC, or the interrupt controller, ROM, RAM, I've got the bar graphs. It looks like I need to move some of my silk screen up a bit. A single ISA slot, which for now is plenty fine. I suppose I could add a couple more slots if I wanted to. But that's starting to come together. This would be a basic board I could now start experimenting with. And like I said, I'm not quite there yet, but this is getting closer.